Hello everyone, myself Jamin Patel, currently working as the data science internet OSS Infobit. So the last task in during of my internship is the car price prediction with machine learning. So the task was to predict the price of the car depending on lot of factors like goodwill of the brand of the car, features of the car, horsepower, and the mileage it gives, and many more. Car price prediction is one of the major research area in machine learning. So if you want to learn how to train a car price prediction, so this project is about that. So this is our code that I have wrote for the car price prediction. And so let us go through this code and see what it is for. First, let us upload the data set which the company has already given to us. Okay, it's initializing connecting, and the data set is already uploaded. So as as always, in the first code, we will always import the important libraries: pandas, SPD, numpy, cbond, matplotlib, and then sklearn, preprocessing, label encoder, variance threshold. Then we will split the data set into train and test, then standard scalar, and then we will say the score of it. So, and for the prediction, we will be using the linear regression model. We will import that from the sklearn.linear model. Now let us read the CSV file into def variable and see the first five records that can be shown by the df.head file. So it is running and we got the first five records of the dataset. It has column named car ID symbol, car name, fuel type, aspiration, door, number of doors, car body, drive wheel, and many more columns. Lot of factors are there for the price of a particular car. Let us see the info of the data set. It has no null count. The car ID and symbol are the integer data type, whereas the car name, fuel type are all objects. And here we get all the information about our data set. So this will describe our data set and give us the mean and standard deviation, 25%, 50% quarterly, 75% quarter, next quarter of all the columns of our data set. And these also the same as that. Now we'll see if there is any null value, and if it is, we will fix that. The number of null values in column, car IDs, invoice are all zero. So there are no null values in our data set, which would be a great to start. So since there are no we will directly go to. Now we will drop the column car ID and car name from that and give it as a company two. Now let us see what are the unique records in the column company. So with this we will get all the name of the companies which are included in our dataset. It has Alfa Romeo, Audi, BMW, Chevrolet, Dodge, and many more car companies. And in this code we will replace if there is any mistake in the spelling, and like for example in this Mazda MA-XDA we will replace it here MA-ZDA if any records are there in of such type. So it gives error, but okay, no problem. But if it is there, we'll require, otherwise it's not. And let us see what we have already seen the companies. Sorry for that, it is again. Okay. So let us move forward and see the plot between the count and the car price. As the car price is increasing, the number of cars produced by the companies are decreasing. So you can see that cheaper cars are in the high number of amount. There are two types of plot here: simple histogram and box plot. Now let us plot a figure of counting the number of cars by the company and the price of that according to the company. So in the first figure, these are all the name of the companies, and these are the count how many cars they are producing. And the graph below it shows the name of the company and the price with which they sell the cars. So Jaguar cars are the most expensive. Then comes the Quick and Bosch, BMW, Volvo. These are some expensive cars where you can see the Mazda, Chevrolet, Nissan sells a car at lower price. So let us see what affects the fuel type on the count and the price. So here we will define a function in which we plot dot figure size 18 by 16. In the subplot 1, that means this subplot 1 comma 3 comma 1, we will plot the count plot on which x will be from the data column, and so that will be plotted. In the second plot, there will be a bar plot where x will be the dot index and y will be defined. Similarly, on the subplot third, we will plot the box plot. X are from DF column and Y is DF price. So this is what it looks. So the gas number of cars that runs on gas fuel are more compared to the diesel. The average price of diesel engine is higher. So car with the diesel fuel type are more expensive than gas. So this is all one of the important for giving direct relation of fuel type to the price of the car. So now let us plot the scatter plot line and line plot combined of the price and the car length and width and height in three subplot. So okay, so let us run that. It's running. So here you can see that as the length of the car increases, the price also rises. Similarly, with the width, as the width increases, the car price increases, but it is not continued in the height. It has the no effect or pattern seen in the car increase in height and increase in price. Similarly, let us see how the engine size, horse ratio, and stroke depends on the price. These are the plots you can do the simple analysis and see on what factors this car price depends. So now let us directly comes to the model part. Uh, uh, we will measure the variance threshold from threshold 0.1 in using where dot fit df new select data type int and float. So we have defined the variance threshold. Now we'll see what are the variants. The company variance is true, whereas the stroke and they are the false vectors. Let us see the heat map. It gives the correlation between all the vectors that are that depend the car price. We will drop the uh, unrequired vectors from the dataset and we will start the split. We will split our dataset into X-train, X-test, Y-train, and Y-test into a training size of 70% of the data. Let us see the size of the train and test set. So it's 143 records for the training and 62 records for the test. Let us scalar transfer the X-train and X-test and let us define the model dot fit X-train and Y-train, then prediction train model dot predict X-train, similarly for X-test, and the R2 score for that, and we will print that. So this will be the linear model, linear regression model, and the training and test scores comes out to be, let us see that it's running, and it is 94% accurate in training score and 87% accurate in testing. So this is how a car price can be predicted using all these factors like stroke comparison and how they are directly related to the price of a car. You can get this code on my GitHub repository, which I will link down in the description. And if you have any further questions, to let me know in the comment and do follow me on my social media.